recording. Cool. So have this out in front of you. Go find it somewhere. Just give me a thumbs up if you either have it or if you're confident that you have everything you need in terms of what's on here. Cool. For those of you watching on YouTube, just go find this note somewhere and make sure you have it with you. Cool. Just everyone give a thumbs up if you're ready. Good, good. Yep, there's good. There's 3. Question, yeah, talk to me.
No, sir, I don't have a.
You're good. Okay, no problem. Sorry, I thought I saw hands up. Okay, so we're not going to do anything.
No,
new
you
today.
did, but yeah. Thumbs up.
Sorry.
I didn't.
No problem, no problem. It doesn't matter. So we're not going to do anything new today. All we're going to do is we're going to play around with this a little bit, and I'm going to show you what the questions could potentially look like. So I'm not going to give you any exam type questions, and the reason is because the exam type questions involve pretty much everything. It's very difficult to find an exam question that's only relevant to a specific, like let's say one functional group conversion. And then also they're going to talk about isomers and other things that we haven't done yet. And the question's just going to look horrible and messy. So what we're going to do is we're just going to play around with it a little bit. And then you can get an idea of what the questions might look like. Cool, so have a pen and paper out with you. I'm going to sort of write a question or make up a question, and then you're going to answer it, and then we'll do feedback, question and answer as we go along. So make sure you've got a writing pad or something with you as well. Cool, and then whatever notes I make here, I'll also put on Google Classroom for whoever's at home, whoever's on YouTube at the moment. Okay, so we're going to start with something simple, just to sort of show you where you can go with this. So they could give you an example like this, and they could say, I'm going to draw everything as skeletal formulas just to save time. So they could say here, this is ethene, ethene, and then they'll give you a reagent, something like HBr, and then they'll give you a little block over here, and they'll call this one product A. And then what they'll do is they'll say, okay, product A is then taken, sorry, let's draw this a little bit better so that you can see it on the screen at the same time. Product A is going to then be taken to product B, and this conversion here is going to be H2O under distillation. Cool. And then the question could ask anything to do with A or B. So let's say, for example, the question says identify product A. And then it could also say identify product B. Not always, not all the time. They ask different questions, but in this case, my question to you is identify product A and B. So what is A and what is B? Cool, so you have ethene, you add HBr. There's no special conditions with the HBr. You can literally just bubble it through as a liquid. Then you take that product and then you distill it to make product B. So I'll pause the video. I'll give you about 3-4 minutes. Draw a structure for A and draw a structure for B. Okay, so who would like to give me product A? Just more or less, what sort of structure do you think it's going to look like in terms of how many carbons? Where's the bromine going to be? What's it going to look like? Anybody feel confident enough to tell me that?
There are going to be 2 carbons,
yeah.
And the bromine is going to be on the second one. And the hydrogen is going to bond it to the rest, and it's going to be bromoethene.
Correct. So the name of the product will be bromoethene. We're going to do naming as a whole long topic later. But like I said, just make sure that every time you read my notes and stuff, just be aware of the names. If they don't make sense, don't worry about it. Just make sure you look at the names every time and see if you can see the relationship between the name and the product. Also, you're absolutely correct. This is going to be bromoethane. Cool. And then what's the second product once you do the distillation with water? Stefan, you can just carry on.
Isn't going to form a hydrogen halide and an alkane.
A hydrogen halide and an alkane. The hydrogen halide is going to be the byproduct, yes, but we don't care about that. So the hydrogen halide is the secondary product. But what's the main product? What's the main functional group conversion? We did this one in yesterday's lesson. It was halogenoalkanes, and we did substitutions.
Wouldn't it be an alcohol?
It'll be an alcohol, correct, 100%. And in which position will it swap out?
At the bromide.
At the bromine, correct. So you'll end up with an OH where the bromine is. Cool. And then absolutely correct, Stefan, you'll get the hydrogen halide as a byproduct, but we're not interested in the hydrogen halide because in organic chemistry, we're only interested in the main or the primary products. So this would be here. We could even call it waste.
So
Yeah.
when we form a alcohol from like an ethene or propene, will it always be like ethanol and propanol?
Ethanol and propanol. Yes, the OL comes at the end, and then where the position of the OL will be determined by the number inside it. But yes, it'll end in OL. So in this case, you don't have to give it a number. It's just ethan for 2 carbons and OL for OH. So ethanol. You'll see later when we do positional isomers, you'll put the number before the OL. So 1 OL, 2 OL, 3 OL, etc., etc. Cool. You happy with that so far?
So
Yeah.
I say now it was an alkene with 3 carbons.
Sure.
On which carbon will the bromine then go?
I'm going to make that as the next question. So you've kind of preempted my next question. So let's do that as question 2. So now we're going to start with propene. So we're going to start with just good old-fashioned propene, 3 carbons, 1 double bond. And then they're going to tell you that it's reacted with the same chemical. So it's going to again be HBr. And they're going to give you 2 blocks like this. And they're going to say, draw the minor product, and they're going to say, draw the major product. Cool. So you can call it minor and major. And then they can carry on, and they can say, take the minor product. So take the minor, and then we're going to react it in this case with NH3 heat and pressure to give product, let's call it X. Cool. So the first one is identify the minor product. Let's call minor product A. Let's call major product B. Then it says take A and convert it to product X. Cool. So have a look at that. I'll give you 5 minutes. Give a thumbs up when you're done.
Gotcha.
Cool. So we're going. So as Kamas, just a skeletal formula. Am I going to have a double bond in my skeletal formula?
In your like the
Yeah,
products.
for let's call it product A and product B. Will I have any double bonds?
No.
No, great. So just give me the basic idea of what shape it'll look like. Just basically I can't really. Never mind. It's like that, right?
Yeah.
Yeah, and then the minor product will have the bromine on the corner here, and the major product will have the bromine on the center carbon. That's what you said earlier. Cool. So you end up with 1 bromo, propane, and you end up with 2 bromo propane. So you get the 1 bromo and you get the 2 bromo. And then they said take the minor product, which is the first one. So they said that take 1 bromo propane and react it with ammonia under heat and pressure. So take this product and then get product X. And what's the only thing that's going to change on the last product X?
It will form an amine.
Correct. Yeah. And where will it be?
I think on the last or the first carbon.
Correct.
It will
correct.
be the bromine will fall away, and I think it will be like
Yeah. In other words, all you're going to do is substitute the bromine for the amine group. So the rest of the molecule stays exactly the same. So you take away the bromine. It's literally a 1-for-1 substitution. Where the bromine came off, the ammonia goes on. And because ammonia has 3 hydrogens to begin with, it has to lose one of the hydrogens in order to bond to the carbon. So that's why you end up with the NH2. Cool. So that's the synthetic route that you would have to take. Cool. And then you could give this one a name, and you could say this is amine. Cool. So propamine. Prop with 3 carbons and amine because there's an amine group on there. So this is propamine. Well, and this is basically a synthetic route. It's saying that I can start with propane, and I can do 2 reactions, and I can end up with propamine. And this is literally what chemists do. I'm not making this up. This is exactly what organic chemists do. They start with a certain molecule, and they modify functional groups until they end up with the molecule that they want. Ooh, so that's how they play around with it. So I'm gonna quickly go back to this over here, and I'm gonna just have a look. What else have we done in terms of groups? Let me just think now. Okay, so as far as we're concerned, there's not much else we can do. So the only thing we can do maybe now is add a bit of complexity. So all we're going to do now is we're just going to make the molecule look a little bit bigger and a bit uglier. Cool. So somebody just give me a number of carbons.
7.
7. So you want 7. So, and you're going to want to branch somewhere. So I'm going to draw it as 1, 2, 3, 4, 5. And I'm going to put a branch somewhere. I'm going to put a branch here. And I'm going to put a branch there. Cool. So that's 7 carbons. 1, 2, 3, 4, 5, 6, 7. Yeah. So it's 1, 2, 3, 4, 5. That's 6 and that's 7. So it's 7 carbons there. Well, they wouldn't tell you that, obviously, that I'm just helping you with that so you can see that. Okay, so 7 carbons. And then give me a position for a double bond between which 2 carbons, which like a double bond?
4 and 5.
4 and 5, very good. So you're going to put at the end carbon over there. Excellent. And then I want you to give me any halogen, bromine, chlorine, fluorine, and then which carbon do you want it on?
Fluorine on carbon 6.
Fluorine on carbon 6. So we got to be careful not to just put the fluorine right there. We have to say that there's fluorine there. Cool. So the carbon is still at the apex, the carbon is still at the corner, and the fluorine is an extra bond over there. If I just put the fluorine there, it means that I've replaced the carbon with a fluorine, so I can't do that. Okay, good. Now we're going to say, we want to do 2 steps. So you've got to think now, let's convert it into one thing and then convert it into another thing. So think of the example that I gave you and think of a way that we can convert this twice. So let's do one conversion first and then do another conversion. So what would be nice to do as a first conversion so that we could get a different molecule? Would you like to do an addition first or a substitution first?
Let's do an addition.
Yeah, perfect. Let's do an addition. So you want steam, so you want H2O, perfect. So you want H2O and you want H2O gas. Oh, very important that I said H2O gas. I didn't say H2O under distillation. So this is not a hydrolysis. Ooh. Then you can say that that would be product A. Cool. And it's going to have a major and a minor. So I want you to only consider major A. So I want you to only consider major A. There is 2 possibilities of where you can add that group. Cool. And then the second one. So now you're going to take that same molecule and you're going to convert it to product B. And what do you want to do for B? Just think about what's going to happen to that molecule and what else can you do to it afterwards. So you've added the OH group. Now what do you want to do with it? So let's do a substitution. So what kind of substitution do you want to do?
Yeah.
Tell me which substitution. We have 3 options. We can substitute for another OH group, we can substitute for an amine, or we can substitute for a nitrile.
Let's substitute for nitrile.
Perfect. So we're going to substitute, we're going to have KCN. And I think, if I'm not mistaken, it's in ethanol. So it's ethanolic KCN. If I'm wrong, don't worry about it. The most important part is the CN here. Okay, so there's the starting product. There's what you're given. You wouldn't be expected to name this, it's overly complicated, but you would be expected to be able to understand the functional group conversions. So conversion number 1 is water. We get 2 different products, but we're only going to consider the major product. And then we're going to take the major product and we're going to react it with KCN in an ethanolic solution to get product B. Cool, everyone happy with that? Any questions? I can't zoom out anymore, unfortunately. Oh no, I can. Sorry, I can zoom out a little bit. There we go. So there's the whole question. It doesn't want to stay at that position, but you get the idea. There we go. Okay, so I'm going to stop the meeting, copy that down, and then come back in 10 minutes. So come back in 10 minutes with an answer. Cool. I'll see you now. Yeah, so log off and then come back in 10 minutes.